Okay, welcome, welcome. If you are joining us today for the first time and have a webcam, please follow the link on the teacher training page to join the Hangout as opposed to just watching it live on YouTube. If you join the actual Hangout instead of watching it live, then you can actually contribute and ask questions. So if you have a microphone or a webcam and would like to make this a little bit more interactive, feel free to join that way. We are going to start today by continuing where we left off from last week, which is we created a paint project, or we started creating a paint project where we had a pencil, and as the mouse moved around, you could paint with the pencil. And there were some challenges that I kind of issued to everyone to make the paint program a little bit more user-friendly and to add a couple features. So we're going to take a look at some of those features today. So the first thing that we're going to look at is our pencil and pen tip, which we started with last week. And I just want to point out a couple little changes or a couple little gotchas from last week to this week. So our pencil is pretty much the same as last week. When we click the green flag, we set the size of our pencil, and then it moves to the mouse pointer and then changes so that it lines up the pencil tip with where our actual mouse is. So that doesn't really change too much from last week. But the pen tip, this is where we've added a whole bunch of things. So I'm going to break this down little by little, piece by piece, to kind of point out what's exactly going on here and why this works. And so again, if you have questions, feel free to write them in. If you're on the YouTube live page, there is a comments window on there too. You can type in your comments there, and I'll be watching those intermittently. Or you can join the Hangout and write your questions in the chat, or just speak up via microphone. So the first thing is, when we talked last week, we had set it up so that you could either tap the space bar to start writing, but in this case, the challenge was to make it so that when you click the mouse, the pencil writes. So in this case, I've changed it so that you actually have to click the mouse, and as long as you're holding down the mouse, it's going to continue writing. Okay, and the way that we do that is we talked a little bit last week about variables at the very end of the training session, and the easiest way to do it is to create a variable that's basically just, is the pencil writing? And there's two options, yes and no, obviously. So when we first start our program, we click the green flag, it hides the pen tip, and then it immediately sets, is the pencil writing, to no. So that way you can move the mouse around freely without it making any kind of marks or any kind of dots or lines or anything on the stage. We've also set the pen color to blue, which I created another variable for that. If you weren't following along last week or didn't get a chance to see it, variables are all under the data section, and they just basically allow us to keep track of things that we're doing in our program. So I've got one for pen size, one for pen color, and then, is the pencil actually writing? And so I'm setting, is pencil writing, to no. I'm setting the pen color to blue, and then I'm actually using the scratch blocks to set the pen color to blue, to the color that we want. And again, you can click on this little block here and just hover your mouse to get the various colors. And then we set the size of the pen tip just to make sure that it's close to the size that we actually want it. Okay, so now, once we have those basics, those first steps set up, then we go into our actual loop. And again, a lot of the times what you're going to do with games and apps is you're going to have loops that go, the things in the loops happen over and over and over again, just repeatedly. They check different things, they perform different actions. But because you want those actions to happen all the time, you need to put them in some kind of a loop. And in this case, we're using a forever loop. I mentioned several times throughout this training that Scratch is just like a normal computer program, or just like a normal computer programming language, in that it only does exactly what you tell it to in the order that you tell it to. So it's really important that the order that we do this stuff in is the actual order that we want things to happen in. So in this case, I'm telling the pen tip, and I'm actually going to show the pen tip just so you can kind of see. So we got that little ball right here, right next to the mouse cursor. That is our actual pen tip. That's where things actually get drawn from, okay? And we're telling the pen tip to go to the mouse pointer, and then if the pencil is writing, then we actually put the pen down. Otherwise, we lift the pen up. So that means that if the pencil is writing as yes, then we write. Otherwise, if the pencil is writing equals no, then we don't want to be writing, which seems pretty obvious, but it helps to see it in this context where we're actually making that decision. We're having the computer look to see if that's true and then performing the two different actions depending on that. Okay, so now I'm going to hide my pen tip again. The other thing that we did, besides just having the mouse draw, is we actually need to check to see if the mouse is being held down. And so when we look at the list here that we have in this first section, these are the pen actions that happen regardless, okay? We need to check if the mouse is held down. And you might think that we could check if the mouse is held down here somewhere. If you look over on the right-hand side, I have a whole nother set of instructions, a whole nother recipe for that same pen tip that just checks, is the mouse down? If it is, set the pencil's writing to yes. If not, set the pencil's writing to no. It's checking if the pen color is red. It's checking if the pen color is yellow. It's checking if it's orange. And then it's setting the pen size. And these things are really important that they're separated because we don't want them to be checked at the same time as these things. If we actually moved these things over here, our program would actually be broken in a few different ways. You might be able to tell a little bit better, but there's a couple bugs that you'll introduce if you just leave this stuff down here. And really, the bugs that you'll introduce are just because of the fact that the order that this stuff happens in changes. So for example, let's say that we're drawing, and it doesn't really look like much, but when I let go of the mouse, the pen still technically draws for a split second after that. And the reason is because as it's going through this loop, it's checking first if the pencil is writing, which at the time is true. So it's putting the pen down. Then we check to see if the mouse is actually being held down. So the order of those things is really, really, really important. You don't want to check to see if the pen is writing before you check if the mouse is down. So we're moving all this stuff over here so that those things happen in tandem. They're two separate loops that are happening at the exact same time, but they're independent of each other. So the mouse is checking if it's being held down at all times. And again, it may be hard to notice because it happens in kind of a split second. So if you're not paying attention, it's not going to be obvious. But with it set up this way, the mouse starts responding and changes that variable immediately as soon as you let go of the mouse, or it starts writing as soon as you press down the mouse. Okay, there's no delay, there's no lag, there's no skipping because of the order of things. Along those same lines, since we're checking if the mouse is being held down, we also want to check to see what the pen color is. That was the other part of the challenge. So the challenge from last week at the end was to create a way to change the pen color within the program, to change the size of the pen, and to clear the screen by pushing buttons. Okay, so some of these are easy, so we'll start with those and then we'll come back to some of these more difficult ones. You can kind of see a preview here of the color change, which doesn't seem too difficult. But let's start with the easy one first, and then we'll go from there. So I think the easiest one is the street cleaner, my erase button. And my erase button, all it does is if I draw something, when I click on this, it clears the stage. Okay, it's really simple because Scratch actually has events under the Events tab here that say when this sprite is clicked. So if you'll remember from last week, and apologies, I'm just gonna mute everyone temporarily here. But if you look at the code for our street cleaner here. In our events section, we have the when green flag is clicked, and last week we talked about that one. We also talked about the when the space key is pressed or any key on the keyboard. But then we also have a when this sprite is clicked. And so what that means is that when the mouse cursor goes onto that object or sprite, as it's called, as you can tell by the window down here, when we click on that, that block gets fired. So you'll see that when I click on it, it kind of briefly highlights in yellow. And that just means that this action is happening. That event is being fired. That event is happening. That sprite got clicked. So when we click that sprite, we clear the pen marks. Okay. Then the next one are the colors. So our next item with the colors is, again, it's pretty similar, but it's a little bit different because we're now setting the pen color. And again, you have a few different ways to handle this, and this is a little bit of a gotcha. So the first method that we can use for this is right here when this sprite is clicked. Some people I've gotten emails or questions about have asked why we can't just use the set pen color to block. Okay, and I'm going to click that color and just set it to red. So technically, this should do approximately the same thing as this, is set the pen color to red. Okay, so I'm going to set it to orange first in Paint, and it is orange. But now when I click on the red, it's still orange. Clicking, still on orange. Still orange. Still orange, and in fact, it's actually painting underneath it when we're clicking. So why is this happening? You might kind of sit here tearing your hair out wondering, I made this work so that the pen color would be red. Why isn't it changing red? It's a really simple explanation, but again, this is one of those coding concepts that unless you know about it in advance or unless you've done it before, it's just a kind of a gotcha. And the reason for that is each object that we have in our program, whether it's a Scratch program or a real program, has its own properties. And just like each object has its own size and its own position of where it is in our program, each object also has its own pen and pen color and pen size and pen, pen properties. So whether it's writing or not, again, what color it is, what shade it is, what size it is, those kinds of things are unique to each object. So when we use this pen color block, okay, all we're doing is setting the pen color of the apple to red, not the pencil or the pen tip that we have. So if we were to actually put in a pen down on here, you'll see, hold on, make sure this is set right. Okay, there we go. So you'll see that the pen is down now. And when we click on it, it should be setting that, but it's going off. Let's try making it a different color and see if that works. I'm actually not sure why that's not working. It might be because our actual pencil is kind of also painting on top of that. So let me see if I can turn this off. Hang on one second. Okay. Pen up. Now let's see if that works. Okay, we have that being clicked. That's firing. I'm just pulling these off so that we can kind of see what's happening with this. Okay, there we go. So our pen tip now, we click on this. Make sure the green flag is set. Just going to add some motion steps so we can see. There we go. So because the actual apple isn't following our cursor right now, which we'd have to set up in order for that to happen, but you can see, let me clear this. You can see as it's moving that it's actually creating that pen color. Okay, because it's the apple, not the pen, that's actually causing that color. The apple has its own pen. So what we actually want to happen, let's set these all back in place, is we want the pen color of the pencil and pen tip to change. And the way that we do that is with a variable. Okay. We keep track of when each sprite is clicked. Put that guy back in the right direction. We keep track of when each one is clicked. And when it's clicked, it changes the variable. So I'm going to turn these variables on so that you can see what's going on. And you turn variables on just by clicking the little checkbox next to them. But when we start our program, you can see that is pencil writing changes as I lift the mouse up and down. And as I click on each of these objects, that variable changes from orange to yellow to red. Okay, so all I'm doing is when I click on each one of those, the apple, the banana, and the orange, it's just setting a variable. That doesn't actually do anything in our program except change this value. But once that value is changed, now we can go into our pen tip and look and see. If that value is red, then we can set the pen color of our pencil to red. And indeed, it does paint it in red. Yellow, if we click on the yellow. Orange, if we click on the orange. Okay, and again, the only reason that we have to do it this way is because of the fact that our objects each have their own pens. So the pen tip and pencil are actually the ones that we want to affect, or in this case, actually specifically just the pen tip, since we're not using the pencil for writing. Okay, so we actually kind of have to do an intermediate step. We have to say, when this object is clicked, set the color to red, which is just text at that point. But then if that text equals red, then the pen tip is checking for what color it should actually be set to. Okay. In a similar fashion, are beetle and dinosaur. So I picked beetles because they're tiny and dinosaurs because they're big. These will raise and lower the size of our pen. So it'll make the stroke on it thicker or thinner, depending on what size it's in. And again, this is very, very similar to what we were doing last time. Which we're using the when sprite is click block. And then in this case, we're using a variable called pen size. And I've created this a little bit differently. Variables don't have any kind of restrictions on them. So technically, if I remove this restriction here, which is if pen size is greater than 1, or on the dinosaur, if it's less than 20, you could technically make the pen size whatever number you want. So if you clicked it 100 times, you'd have a pen stroke that's 100 pixels wide. That's not very useful. So I just added a little restriction here that it has to be at least 1 pixel in size, or at least size 1. And at the maximum is size 20. It won't go past size 20. So it doesn't matter how many times I click it. You'll see that's kind of a pretty thick stroke anyway. And then I can lower the stroke down here. Okay, and again, I did that with a variable, and that variable pen size is here, and I've moved it here so that you can actually see in the program what size the pen is. So in this case, it's 1. Click a couple more times, that's 7, and so on and so forth. Okay, but you'll notice again that I have to use a variable, because if I just change the pen size on these two objects or these two sprites, then it's only going to change the pen for those objects. It's not going to change our pen tip. Okay. So it's important to know that the pens are different. Each object has its own properties, and we want to make sure that we're changing the properties of the right object. Okay. So I'm going to make this project available on the teacher training page so that you can see, kind of go in here, study, look at the inside of the program and see all these different code blocks. I encourage you to copy it when you open up a program in Scratch, or when you go into a project in Scratch. You have the option on this main page here to create a branch or a remix of this. So because this is my project, I won't be able to show you here, but you'll have buttons on here to make your own version. You can start with my version of the project and kind of work past that. So I would highly recommend that everybody does that everybody goes through and at least tries to kind of look at the inner workings of this and see how it works. So. Okay, so I am going to unmute everybody now. I'm going to open up the comments on our YouTube channel. If you have any questions on this section right now, we have some more things that we're going to be going over today, but I just want to field any questions that anybody has related to this project. So let me go ahead and unmute everybody. And actually, it looks like I can't mute everybody or unmute everybody. So if you have a question, feel free to unmute yourself if you're in the Hangout. And then if you're on YouTube, like I said, feel free to just leave a comment on there and I will check it out. I'll give you a couple minutes in case you have any questions. There's also a chat in the Hangout. If you move your mouse to the left-hand side of the screen, there's some boxes that'll pop up, and one of them is a little blue word balloon with some white letters. You can also write questions in there, and I will take a look at them. Tracy asked, where did you say we can get a copy of the project? I will put it up after today's training session is over. I will put a link on that teacher training page. So when you, let me just pull up my teacher training note. It should just be sparkappleague.com/teacher-training. And I'll put this project up here at the end as well so you can see it, but that's the address right there. sparkappleague.com/teacher-training, and all the info for every single one of the teacher trainings will be on that page so that you can take a look at it. All right. Any other questions? I don't have any questions on YouTube. Okay, great. I'm going to mute everybody again. And then, like I said, if you have any questions or anything, feel free to just unmute yourself and ask whatever questions you need. Okay, so now I'm going to start a blank project, and we're going to go over a couple of kind of items that are going to be nice to know for the upcoming competition. Every year we have a different theme and a different kind of goal that the students have to do in each competition, and they have to follow certain rules. Or not necessarily rules, but there's some guidelines that we have that each project needs to follow. They're not hard and fast. They're kind of a little open-ended. But these tips kind of and tricks that I'm going to show you are going to come in very, very handy for students that are entering into the competition or that are going to be at the competition. So the first thing that a lot of students have questions about, because it comes in to games and in different apps all the time, is how to figure out if two different objects are touching, okay? And again, there are some gotchas with this, so I'm intentionally going to do a few things incorrectly in order to just kind of point out certain things. So first off, I'm just going to add a new object. So under the sprites window here, I renamed Scratch the Cat. I clicked this little letter, blue circle with a white letter I in it, and I named him Scratch the Cat just so I can differentiate it. But I want to choose an object, and I'm going to choose a soccer ball because it's pretty easy to tell if those two things are you know, they're completely separate, completely different things, so there's not going to be any confusion. But we want to see if these two objects are touching, and I'm going to start off by maybe making it so that Scratch can kick the ball when we move to it. So really quick, and again, if you missed this last week, then feel free to watch one of the old videos. I'm going to do this pretty quickly. So it might seem a little bit confusing, but I'm just putting in some basic controls so that we can move Scratch the Cat around. So all I'm doing right now is I'm saying, if I'm pressing the right arrow key on the keyboard, I want to make sure that Scratch is pointing in the right direction, and I want to move him 10 steps. Whoops, and I actually did that on the soccer ball. So notice that I have the soccer ball highlighted here. That's the code that I'm actually working on. I need it to be on Scratch the Cat because that's the actual character that we're going to be moving around. So one of the nice things about Scratch is you can just drag stuff from one character to another. It'll still stay in your current character, but it will copy it to the other object or the other sprite as well. So I can get rid of these. Okay, so if Scratch the Cat, when I click the green flag, if I'm pressing the right arrow key, Scratch the Cat is going to point to the right and move 10 steps. And if the left arrow key is pressed, then I'm going to point him in the other direction. So I will choose left, and then he'll move 10 steps. I'm also going to change the size of both of these objects. So that way we have a little bit more room to move around. Perfect. And then I'm going to add in a when green flag clicked and set the size of this guy too. Okay, that's a little bit more manageable. So now, if I move my arrow keys, Scratch the Cat can move left and right. And again, if you were here last week or you looked at the previous teacher trainings, you'll notice that there's some stuff we got to change about how Scratch rotates. But we're able to move left and right. Okay, so what I'm going to do now is I'm going to set it up so that if Scratch the Cat touches the ball will also move in whatever direction he's moving. Okay. So first, to make this fun, I'm going to click in the sprites window here. In the bottom left-hand corner, I'm going to click on the backdrops. And I'm going to load a new backdrop from the Scratch library. And I know that there is a goal here, so we'll use this guy. And we'll put Scratch on the field. We'll put the ball also on the field. And I'm also going to add an up and down direction so that we can move Scratch around the ball. Again, hopefully this makes sense. If it doesn't, we touched on all this stuff in last week's teacher training. So be sure to take a look at that if some of this doesn't make sense to you. All right, so now I hit the green flag and I should be able to move up, down, and all around. Okay, perfect. So now the soccer ball. We want to check to see if these two items are touching, okay? And most people will start off by going to the touching, scratch the cat. So again, we have our sensing blocks, the same way that we could check to see if the spacebar is being pressed or another key is being pressed. We can check to see if the object that we currently have highlighted, in this case the soccer ball, is touching one of our other objects. So it could be the mouse pointer, it can be the edge of the screen, or it can be one of our other objects, which in this case is Scratch. So you might think, if touching Scratch the cat, then move 10 steps. And that probably seems like it works. Oh, I have to hit the green flag. Okay, it's not working. Okay. And it might not be obvious right from the get-go why it's not working. But again, and I stress this over and over again, it's only going to do exactly what you're telling it to do in the order that you tell it to do and when you tell it to do it. So just like with Scratch the Cat and just like we saw in one of our examples last week, checking this if condition, it's only checking to see if this is true or not when we click the green flag. Okay, so if I move Scratch the Cat on top of the ball or underneath the ball and hit the green flag, you'll notice that our ball moves then, but as soon as it's not touching him anymore, the ball doesn't move, it stays still. Okay, and the reason for that is, again, because it's only checking this condition when the green flag is clicked. So we need to fix that. And again, just like we talked about before, the easiest way to do that is to make sure that that condition is being checked over and over and over again. Okay, and you can do that easily by either choosing a forever loop, or there's some more complicated methods to setting this up that might actually give you better results depending on what you're trying to do. But the forever block will just repeat that over and over again. So now if I hit the green flag, Scratch the Cat, I can essentially kick the ball into the goal. Okay. Another little mistake you'll probably see, though, is if I move to this side of the ball and try kicking it, it still goes to the right side. So we need to figure out which side Scratch the Cat is actually touching. Okay, that might not be immediately obvious. I am going to add a little motion block that just moves Scratch and our ball back to their starting positions whenever we hit the green flag. So let me do that really quickly. And point them in the right direction. So when the green flag is clicked on the ball, I'm setting the size to 20% so that it's about the same size as Scratch. I'm moving the ball here, and then I'm doing my loop. So now at least I can move the ball into the goal, but when I hit the green flag, they both reset back to their original positions. And then Scratch the Cat, again, when I click the green flag, he's going back to his starting point, making sure he's facing to the right, setting his size so it's closer in line to the size of the soccer ball. And then it's doing all of our steps, all of our recipe steps. So there are multiple ways that we can actually do this. There are multiple ways that we can check which side Scratch the Cat is coming from. Okay, I'm not going to tell you which way is best or which way is the right way, because really there isn't a right way. Depending on what the project is doing and how the project is functioning, you may come up with multiple different solutions for different scenarios, for different things. I'm bringing this up because there's a very specific way that we can set this up. Okay, and we might even have time to do 2 different methods, but I'm going to try first with just one. Okay, and the way that we're going to do it is we are going to create ghost blocks. And ghost blocks, it's kind of a slang name for something that is done in Scratch all the time, that is a kind of a trick that programmers use when they're trying to get the computer to do something that's not necessarily really easy for the computer to do. So in this case, just as an example, we don't really have a way for Scratch to tell if the player is coming from the left-hand side or the right-hand side. We only have the ability to check if it's touching that character. Okay, we can set up some variables if we want, or we can use these blocks here that allow us to check to see if Scratch the Cat's X position is less than or greater than the X position of the ball. So if it is less than the X position of the ball, that means he's obviously coming from the left-hand side. If it's greater than, then it's coming from the right-hand side. And that's a really easy kind of mathematical way to figure out whether something is to the left or to the right of our character, or whether our character is to the left or right of something. But I'm going to kind of introduce you to this ghost blocks concept. And really the main gist of it is, if I come in here and create a new sprite, this is going to work very, very similarly to our pen tip from the last exercise. And the pen tip, basically what it does is it creates a block. So I'm going to make a block here and fill it in. And I just need to make sure that I don't have these colors anywhere else in my project. So I'm just going to pick two somewhat unique colors. And then I'll fill this in. Zoom in a little bit because I have, there we go. Okay, so now I have a block that has two very distinct colors. Okay. I'm going to shrink this so that it's about the same size as our soccer ball. Okay. And just like we did with the pen tip or the pen tool, I am going to tell the pen tip, or sorry, the ghost block. So let me just name this ghost block so that this makes sense. I'm going to tell the ghost block to do whatever it is the ball was supposed to be doing. So I'm going to grab these and drag them onto the ghost block. And now I have a copy. So now when I start this, they should end up in the same spot. I'm going to disconnect these temporarily. And so ultimately what's happening is, rather than the soccer ball moving, we want this ghost block to move. Okay? And then the soccer ball, all the soccer ball really needs to do, again, just like the pen tip from the project last week, is it just needs to go to where the soccer ball is. Or sorry, the ghost block. Okay, so you'll notice that the ghost block is moving around and the soccer ball is following it. Again, we haven't fixed our issue yet of the direction, but at least in this case now, the soccer ball is following the ghost block, okay? But the benefit of this ghost block, the whole point of why we've created it, why it exists, is because Scratch has the ability to sense whether one color is touching another color or whether a character is touching a color. Okay? And what that does is we can check to see if Scratch is touching the black side of the ghost block or if he's touching the other side of the ghost block. Okay? And based on which side he's touching, we can change the direction that the block moves. Okay. Let me just get rid of some of this stuff here. So all of our, oops, didn't mean to click that. Okay, so all of our actions, all of our actual programming logic is going to happen on the ghost block, and the soccer ball is just going to follow it around. So because we have it set forever to just go to wherever that ghost block is, that's just going to follow it around forever and ever and ever. Okay, and so let's check. We have two different things that we can do. So one, we can say, I'm going to do it one way, but you can also probably set it up a different way as well. Obviously, like I said, there's more than one way to do this. But I'm actually going to check to see if Scratch the Cat is touching that color. So I'm going to add another block here after our arrow keys and check if Scratch the Cat is touching black first. And then I'm going to check to see if he's touching the other color. So now I have two blocks. If it's touching this color, then do this. If it's touching that color, do that. Now, as you may have already kind of seen from the last example that I gave, where each object has its own properties, we can do this one of two ways. We can check to see if Scratch the Cat is hitting the ghost block, or we can check to see if the ghost block is hitting Scratch the Cat. So you could just the same, instead of making the ghost block be following the soccer ball, or sorry, the soccer ball following the ghost block, you could have Scratch the Cat be the ghost block and check to see if the soccer ball is touching the right or left-hand side. It doesn't matter which direction you do this in or which object is checking for the other object, as long as you have one object checking the other object. So I'm checking to see if Scratch the Cat is touching the block. And then if he's hitting the black color, then I can do one thing. And if not, then I can do another thing. And so the way that we're going to get the actual ball and ghost block to move, so we're going to disconnect these things. And we're going to introduce something called messages. Okay? And messages, or sometimes people refer to it as broadcasting, is a way to do custom events. So as we talked about, Scratch has a bunch of different kinds of events that you can do, which one is when you click the green flag, that is an event. Something has happened. We've clicked the green flag. When the space bar key is pressed, that's an event. When we click on the sprite, that's an event. Well, we have these little blocks down here that are called broadcast blocks. And what they do is they create a new event, a custom event that we decide. So I can say here, for example, broadcast message, and put in a new message that says hit from the left, or kicked from the left, I should say. And if I drag that in, what's going to happen is if Scratch the Cat is touching a black box or a black color block, then our program will send out a message to every other object in our game or in our app that says kicked from left. Okay? That doesn't really mean anything until we set what that means or what that does. And the way that we do that is we can go into the ghost block now, and we can actually set a set of steps. So just like we have an event for when the green flag is clicked, we also have an event now for when I receive that message, that kicked from the left message. So when the ghost block sees that it's been kicked from the left, it's going to do these steps. And those steps are just going to be, we're going to point it to the right and move it 10 steps. Actually, I'll do 20 steps just to make it kick farther. Okay, and we're going to do the same thing from the drop down. We're going to choose new message and pick kicked from right. Now, if it's coming from the other side, we're kicking it from the right-hand side. And we'll use that new event when I receive kicked from right instead of kicked from left. And now we're going to point it to the left and move it 20 steps. So let's see if this works. Stop our program, start it up again. Everything resets back to its spot. Scratch the Cat is kicking to the right. I move to the left. It looks like it doesn't matter what direction he's following us in. The ball is in fact moving left and right. Okay. One thing that you'll need to look out for, that you might be seeing happening here, is that it looks like our blocks are not big. Oops, undo. Our blocks aren't big enough. We may actually want to have larger blocks here so that we can tell a little bit better if Scratch the Cat is moving to the left or to the right. I'm going to delete this whole thing and start. Okay, so ball's being kicked in the right side. Okay, and you'll notice that there's an issue with this. And part of the issue is that Scratch the Cat, that might have been the wrong color. Hold on. There you go, let's try that now. You might have noticed an issue already, and that is that the ball's kind of moving away from Scratch regardless of what direction he's going in. Okay. This is another one of those gotchas that kind of trips people up all the time. We have set our project right now that when the ghost block gets a kick from the left, we point it in a direction and then move it a certain number of steps, okay? As you saw with Scratch the Cat, though, the direction changes. It actually flips the artwork or the costume of our character around so that when I move Scratch the Cat left and right, you'll notice he faces a different direction, okay? And that's exactly what's happening here with our block, is it's switching directions when we go to kick it because we've told it to point in a different direction, okay? So instead, I'm going to disconnect these. I'll keep them here just for reference so that you can see. But we also have another way to move items, and that is that we can just change the X and Y coordinates by certain values. So I'm actually going to use that instead. When we kick from the left, we want to change the X by 20. And when we kick from the right, you want to change the X by -20. Okay, again, negatives are to the left, positives are to the right. Just to make sure that it's pointing back in the right direction, I'm going to set the point in direction block here. So now we have black on that side. And now if I reset this and restart it, it should work the way that we intended it to. So now we can kick the ball left and right, unless we go off the edge of the screen. Right, left. Okay. So again, as I said, it only does exactly what you tell it to do in the order that it tells you to do it. So in this case, we need to be sure we can't use these point in direction blocks because that actually changes the direction that our character is facing. Now, if you joined us last week, another solution to this, and again, as I've mentioned, there are multiple solutions to these problems. Another solution would be, rather than using these X, Y values, if you're not comfortable using those and you'd rather point it in a direction and move it a specific number of steps, you can go into the properties, this little letter I, the info for that object, and we have a rotation style that doesn't actually change the costume position, so it will always stay the same way. You can do that as well. I hesitate in doing that because eventually we may actually want to set this up so that we can kick the ball around or have it bounce or do various different things. And if it doesn't actually rotate in certain directions, then it's not going to work 100% correctly. We may even want Scratch to be able to kick it up or down or left or right or whatever, and we might need to add colors to that. So depending on how you do that, you'll need to make sure that the ball actually does rotate or that you're able to point it in a specific direction. So again, more than one way to do exactly the same type of thing. In this case, the big idea, the big takeaway here is that we're using this ghost block to determine which side of the ball is being hit. And we're using two different colors. Now, obviously, this doesn't look that great because our ball is being covered up by this ghost block. But that's why we have some additional items that we can use within Scratch. And one of the items is the ability to hide an object so that when we start our program, we can hide it. Okay, but notice how that stops Scratch the Cat from actually being able to do it because we're no longer touching the color. That color doesn't exist because we've hidden it. Okay, so a trick that I've kind of taught in the past, and this works for any number of things. It comes in really, really handy when students are trying to animate things and they're trying to make things appear and disappear off the screen, but they still want the character to be able to interact with them. And that is under the Looks tab, there's an effect called Ghost, and it's in this block here that says Set Color Effect. There's multiple effects that you can use on a block, and there's color, fisheye. Some of these are really cool, and they do kind of some warpy effects. Pixelate turns it into like a more 8-bit image. You have mosaics. You can make something brighter or darker. But one of the effects is called Ghost, and the Ghost effect is what's called a transparency effect. So if I set it to 150 and then start this, our Ghost block will show up. And actually, we can set it to, let's do 50 and see if that works. Okay, that's a little bit better. So I think these values might go up to 100. And if you start at 0, then you see the full block. If you go to 100, then the block is completely hidden. So it's a percentage. But this effect still allows you to have things kind of detect each other. So if I set this to 50%, it might be because I'm using the color check. So let's double check. Let's do some debugging here. Wrong one. Okay, this one's going to be this color, and this one is this color. Okay, so now if I start this, I have to find the right color for this. Ooh. Let's try black again. Oops. I think it's because I'm using the colors, and since I have a background, it's probably what's going on here. It's not detecting the exact colors. Tracy's asking, would it work if the sprites under the eye section unchecked show? I don't think so, but let's check. No, that's the same thing as the show and hide pieces here. I'm going to just test something really quick. And this is just to see. Just make sure this works. Okay, so it works if I set the ghost block. It is because of the colors. The colors are not working 100% correctly. But you'll notice that even though I've set the ghost effect to 100%, I'm still able to interact with that block. So I just need to set some additional items. So maybe this is where we can go into that option number 2. Okay, so last week we talked about a couple different items. We talked about operators, which we don't talk about too often unless you're doing kind of math calculations. But as I mentioned earlier, one of the ways that we can check the left and right side of the ball is also if the X position is greater than or less than. So I'm going to put that in for now, and I'll have to see what's going on with my ghost block colors. I might just be forgetting something. But I'm going to do a less than and greater than comparison. So all I'm going to do is check to see if scratch the cat's Y position, or sorry, not Y position, X position is less than the X position of the ball, or if it's greater than the X position of the ball. So here I'm saying if the X position of the ball is less than the X position of the ghost block, then that means it has to be on the left-hand side. If it's greater than, then it has to mean that it's coming from the right-hand side. That looks like it's working. And I think I may have just figured out what my issue was. So here's one way to do it. And I'm going to show you the other way that I intended initially, because that's the one that I wanted. And that was, we actually need to have 2 separate objects, one for the left-hand side, one for the right-hand side. So I'm going to delete this from here and delete that from here. So I'm going to rename this one ghost block right, and this one ghost block left. That way we know for sure what direction it's coming from. I, for whatever reason, totally missed this and put him as one object. That was our mistake there. So now ghost block left, ghost block right. kick from left, kick from right. And I just need to make sure that each ghost block's position, the soccer ball's position is not at exactly the same spot as each ghost block. There's two. Okay, so I have two ghost blocks here, one right after the other. You can kind of see how that's working. Now if I set the ghost effect to 100 on that one and 100 on this one, it works the same way. So you notice even though we can't see it, it's still actually interacting with it. It's still interacting with that object. A couple other situations where this comes in really, really, really handy is if the kids want to make like a race game, or if they want to see an example that we've used in the past is we had like a memory type game where you had multiple objects from different categories and you wanted to see if those objects were touching each other and they also belonged to the same category. Easiest way to do that is just to create a ghost block that each of those items follows around, and that the ghost block itself is what determines what category that object is. So this just lets you do logic on multiple different objects or multiple types of objects where the look of the item or the object or the sprite is different from what is actually being checked to see if that stuff is true. So in this case, we're checking to see if this block is left or right, but we actually need two different objects to check to see what direction this is coming from. Okay, we can't do that with one object. We need two objects. So if we wanted to check to see if it was coming from the top or bottom, we'd need two more objects. So then we'd have 4 total that would help determine what direction the item is coming from. And sometimes, I'm going to use this just as an example, and then we'll be out of time here. But a lot of the times, you'll end up with something that looks like 4 triangles, and each of the triangles are different colors. That's a good way to check the top, bottom, up, down connections. So this would be like our top, and then we would draw a different color, and this would be our bottom, and then we would fill that in. And then again, you can split these out afterwards into separate objects or separate colors or whatever you need to determine that. But then each one would kind of tell you, use these almost as like sensors to determine what direction the actual object is coming from or what direction is being interacted with. Okay, so we're going to continue on with this as we go forward in the week. The topic is going to be the same. It's the same all week. So we're going to talk about different ways that we can check to see if items are interacting with each other. Part of what we're going to be doing is checking to see if certain items, as I mentioned just a few minutes ago, are from the same category or different categories, or if an object kind of belongs. So we're going to do a small game where you check to see if a block that you put into like a goal is the right block. So each level of the game will have a specific combination or a specific set block that needs to be put into the goal, and then it'll check to see if you got the correct block into the correct goal. Okay, I'm going to stick around for a couple more minutes for, again, additionally any questions that you have. Next week, if you don't come to the remaining sessions for this week, I'll still be publishing those on YouTube, and we'll have them available on the teacher training page. But next week, we have some special guests coming in. We have some guests from the Smithsonian Institute, the Lemelson Center for Invention and Innovation. They're going to be talking about some of the kind of the theme of our event. Again, we're not going to give the students the specific theme, but they're going to talk about some of the general themes that we're really trying to get across with this event. And then we also have a special guest from ASU Polytechnic, from the Fulton Schools of Engineering, Christina Karaskia. She is a graphic information technology lecturer who's going to talk about the design of apps and games and how students can also use the tools that we have in Scratch and otherwise to kind of make the games a little bit easier to use, easier to follow. Just going to talk about user-centered design and about graphics as well, what graphics and colors and things like that mean. So if you have any other questions, I will hang around. Otherwise, I'll see you next training session or next week. And let me know if there's anything we can improve or if there's anything we can help you out with. All right? All right, we're open for questions, so let me know if there's anything else. Again, both on YouTube, in the chat here, or if you just want to unmute your mic, feel free to ask any questions you have. Tracy is asking, could we duplicate the soccer ball and recolor sections of its use for the ghost block? Yes, absolutely. In fact, if you recolor the soccer ball, you could potentially make it whatever sections you want. The big thing is that you'll need separate objects for each direction or for each item. So just depending on what you're trying to do, yes, you could duplicate it and recolor it and do that stuff. That way you wouldn't even technically need a ghost block. So, you know, this left black spot here, you can make that red. This top one could be yellow. You could maybe move one of these or make this one blue and then the bottom one black. And then you could just use the initial method that we used, which was just checking if it was touching a specific color. That would definitely work if you wanted to do that. Again, the ghost blocks are really helpful. And I would really recommend too, if you go into the main Scratch page, I feel like enough people don't do this, but if you go into the Explore section here at the top, there are tons and tons and tons of examples. Ghost blocks are also sometimes called hitboxes. And so you can kind of look at other projects that have done these similar items or done these similar things to see how they did it. Every single project that's available on Scratch has the option for you to look inside that project and see what's going on, how did they do what they did. So a lot of the times you'll see hitboxes and you know, various concepts like that shown through other people's projects. So check it out and see how other people have done this. The main point is just that with the ghost boxes, it's when you need different things to happen that you can't have happen to one object all at the same time. Again, next week we'll use another example that might be able to show that a little better, because we have a very specific example that we're using, which is to check and see if something is in the right spot or if it belongs to the right category. Oh, here's a good one everybody knows. Mario Brothers. So see, we've got a hitbox here. This is a little bit more complicated, but they're using, it looks like, a hitbox to show off like the warp pipe and stuff. So depending on what area of the level you're on, you can see kind of what the player is actually checking against. So I think it looks like they're probably checking to see if you're touching black, because it looks like that's what they used for all this stuff. But hopefully that makes sense. Hitboxes are also really useful too for if you have characters that aren't like perfect squares or perfect, perfectly shaped to what you would think that they would normally be shaped as. You can simplify a character. It happens a lot on cars. People make like cars or vehicles, and the vehicles have like really jagged edges and stuff. And then you put them on the race tracks or on a course, and it gets caught on the various different corners of the course. So sometimes people will put a ghost box behind the actual car so that you're only checking for actual hits on the box as opposed to the detailed blocks of the ship. I'll try and find a specific example for next week so you can see that. Any other questions? Okay, I'm going to hang around for a couple minutes more in case anybody else does have any questions. Couple viewers on YouTube being very silent. Here's one that we created last year for Students Fair. Does Scratch have a layering system to hide objects underneath each other? It does, actually. You have under the Looks tab, there is a couple blocks here, go to front and go back X number of layers. So it's not very sophisticated, but it does have a basic layering system that you can use. Oh, actually, here's a great example of ghost blocks that I used. Let's see. So we made a racing game here, and to check if you were going on like the grass or that the cars were going to another spot. I think this one might be broken. Hang on. So I made a bunch of different cars. And you can see that the actual cars themselves aren't what's racing. It's these sensors that we created that are racing. And the sensors have a red side and a blue side and a yellow dot in front of them that checks to see if they're going to turn into something, into the left of something, or into the front of something. And so then the actual cars themselves, those just kind of follow you or follow those sensors around. So I don't think we ever finished this exercise last time, but the cars then basically were going to be set to go directly to, you know, wherever that sensor was. But you can kind of see them going around the track. The sensors are actually moving around the track and racing. I was thinking that would help with hiding the object if we were checking the colors. Yes, definitely. You can definitely layer stuff on top of each other. I think the only issue I can see there is if the item that you're putting on top, that you're hiding the stuff underneath to check the colors with, is not big enough to check those colors or to cover them. I mean, so you definitely could, if you wanted to do, like, for example, that triangle setup that I was showing earlier where you have a triangle for the up, a triangle for left, down, and right, you'd have some of those colors sticking up around the sides of the soccer ball. So that wouldn't exactly work. But again, that's exactly what the ghost effect is for. It's to hide those types of things where you're not getting exactly the right colors to show up, or stuff's poking out from behind other stuff. But yes, if your objects are the same size and you're trying to use those, then definitely you could use the layering to hide stuff. And you can even layer multiple things on top of each other if you want to cover a bunch of different things. So that's actually another thing too. You could take, like if you wanted the soccer ball to be at the front, delete this guy. But if I take the ghosting effect off of the ghost blocks and set them to 0, so now the soccer ball is on top of that, but notice that the ghost block is still kind of hiding behind it. I can change those. I can obviously resize them and stuff, but I just wanted to set it up so that Scratch doesn't exactly have to be touching the soccer ball. So it just depends on how specific you want it to be. Okay, any other questions? If not, I still don't see any questions on YouTube, so I'm guessing that our YouTube viewers are just kind of playing in the background or something. But if you have any other questions, feel free to reach out on our website. We also have a Slack channel set up. If you go on the teacher training page, there's instructions on how to get registered for Slack. You do have to ask for an invite, so feel free to email me if you would like an invite to that, and I can answer questions throughout the day if you're working on this in your free time. Or just send me an email, admin@sparkappleague.com. And we will see you guys tomorrow. And then if you're not attending the rest of the sessions for this week because you feel pretty comfortable with this stuff, we'll see you next week with our special guests, Smithsonian and ASU's Fulton Schools of Engineering. So thank you everyone for attending. Have a great day, and we'll see you soon.